Most people assume the nuclear age came to American roads in the form of fantasy sketches drawn by designers who had watched too many science fiction films. Chrome fins, atomic symbols, wishful thinking. But in 1958, Ford Motor Company's engineers produced something that was far more than a publicity stunt. It was a genuine engineering proposal, backed by real atomic science, built as a detailed scale model, and presented to the world as a plausible, near-future vehicle. The designers had thought through the propulsion system, the shielding requirements, the refueling infrastructure. This was the Ford Nucleon. And the story of how it came to exist, what it actually proposed, and why it never made production, is one of the strangest chapters in American automotive engineering. To understand the Nucleon, you need to understand what nuclear technology looked like in 1957 and 1958. The USS Nautilus had completed its first nuclear-powered voyage in 1955, proving a compact reactor could drive a vessel continuously for thousands of miles without refueling. The Atomic Energy Commission was actively funding research into smaller reactor designs. Shippingport Atomic Power Station came online in Pennsylvania in 1957, the first commercial nuclear plant in the country. The technology was accelerating fast. Ford's engineers weren't operating in a vacuum. They had access to published reactor research, AEC reports, and a genuine institutional belief that compact nuclear propulsion was coming. The only question was what form it would take. Ford's advanced styling studio in Dearborn developed the Nucleon's physical form under the company's product planning group. The scale model was built at 3/8 of full size, which was standard practice for concepts not intended for immediate production. What made it striking right away was the layout. Unlike every American car before it, the Nucleon pushed its power source completely to the rear. The passenger compartment sat at the very front of a low, swept body. Behind the cabin, mounted over the rear axle on an elevated cantilevered deck, was the reactor pod. The whole rear of the car was essentially a nuclear power package, nothing remotely like it had ever been proposed by a major American manufacturer. The reactor itself, as Ford's engineering team conceived it, would not use conventional combustion at all. The design called for a small pressurized water reactor housed inside a shielded capsule. Heat from controlled fission would generate steam, and that steam would drive a turbine connected to the drivetrain. The turbine output would power the rear wheels. Ford's published descriptions of the system referred to the reactor capsule as interchangeable, meaning drivers would not refuel in the traditional sense. When the uranium load depleted, you would drive to a service station, swap the old capsule for a fresh one, and continue on. Ford's engineers estimated a single capsule would carry the car approximately 5,000 miles, roughly the driving distance from New York to Los Angeles and back with room to spare. The shielding was where the engineering got genuinely complicated. Placing any fission reactor near human occupants requires substantial radiation protection, and in the 1950s the materials capable of providing that protection were heavy. Lead and concrete were the standard options. Ford's approach was to use the reactor's rear placement and the physical distance between the power capsule and the passenger compartment as the first line of defense. The cabin was pushed as far forward on the chassis as physically possible. An internal radiation barrier between the power module and the occupants would provide secondary shielding. The designers understood that any production version would require significant advances in lightweight shielding materials that simply did not exist yet. That was the honest acknowledgement embedded in Ford's presentation of the Nucleon. The company never claimed the car was ready to build. The 1958 scale model was explicitly presented as a projection of what might be achievable once reactor miniaturization reached a sufficient level. Ford's engineers were betting on a trajectory. They believed reactors would keep shrinking throughout the 1960s. If a naval reactor could power a vessel the size of the Nautilus, then surely, within a decade or two, a reactor small enough and light enough for a passenger vehicle was achievable. That BET never paid off. Reactor miniaturization hit hard physical and regulatory limits that the Optimism of 1958 could not have fully anticipated. The Nucleon's exterior styling reflected the full visual vocabulary of late 1950s American futurism. The car rode on a long wheelbase, with the passenger compartment suspended between two forward pontoons at the front and the raised reactor deck at the rear. The roofline was low and swept, almost tailless at the front. Twin fins framed the reactor housing at the rear, which sat elevated above the main body surface on a structural pylon. The whole silhouette looked like something halfway between a conventional automobile and a small aircraft fuselage. Ford produced three distinct body-style proposals: a sedan, a pickup variation, and a larger transport version, all using the same rear nuclear power module architecture. It was genuinely wild, even by the standards of an era when American concept cars were already pushing hard against the boundaries of reason. Inside the cabin, Ford's designers envisioned a cockpit rather than a conventional interior. The driver sat centrally positioned in the forward section, flanked by instrument displays reading reactor output, turbine speed, and power settings. Conventional controls were replaced with simplified inputs, since a steam turbine drivetrain has fundamentally different operating characteristics from a piston engine. There is no conventional throttle in the traditional sense. Power delivery from a steam turbine is inherently smooth and continuous, without the torque peaks and valleys of an internal combustion engine. That was actually a genuine engineering advantage the Nucleon's designers highlighted. Turbine power to the wheels would have been extraordinarily linear by any standard of the era. The scale model toured Ford's exhibit circuit and generated substantial press coverage. It appeared in Popular Science and several automotive trade publications. The reaction was a mix of genuine fascination and considered skepticism. Engineers who read Ford's technical briefs acknowledged the internal logic of the design. Reactors were getting smaller. Shielding materials were improving. The turbine drivetrain concept was not inherently unworkable. What gave serious engineers pause was the scale of the gap between technology that existed in 1958 and the technology required to actually build it. A reactor small enough to fit in a car, light enough not to destroy weight balance, and safe enough for civilian operation was not simply a scaled-down version of existing hardware. It was a fundamentally different engineering problem. The nuclear car was not uniquely a Ford idea. General Motors had its own atomic age concept, the 1958 Firebird 3, which incorporated styling cues referencing nuclear age aesthetics throughout. Simca in France produced the Fulgur concept the same year, also proposing atomic propulsion. The entire Western automotive industry was in the grip of the same optimism. The post-war atomic age had convinced engineers and executives across every major industry that nuclear energy was the inevitable future power source for everything from household appliances to long-distance aircraft. The Ford Nucleon was simply the most thoroughly developed automotive expression of that belief, with the most detailed engineering rationale behind its layout choices. Chrysler took a different approach entirely. Rather than proposing nuclear fission, Chrysler's turbine program pursued gas turbine propulsion as a working alternative to the piston engine through the late 1950s, culminating in the 1963 Chrysler turbine car. Chrysler built 55 turbine cars and loaned them to members of the public for extended real-world testing between 1963 and 1966. But the turbine had its own insurmountable problems: poor fuel economy, slow throttle response, and extreme heat output from the exhaust. The comparison to the Nucleon is worth drawing because both programs represented the same institutional belief that the piston engine's dominance was temporary. Both were ultimately wrong about that. The regulatory environment surrounding a nuclear-powered civilian vehicle was a problem Ford's designers acknowledged, but largely set aside. In the 1950s, the AEC, the Atomic Energy Commission, controlled all nuclear materials in the United States under the Atomic Energy Act of 1954. Any civilian use of fission material required licensing, inspection, and ongoing regulatory oversight that did not translate to a consumer product. The idea of a network of nuclear refueling stations staffed by civilian service attendants handling spent uranium capsules raised questions Ford's concept never fully resolved. The engineering vision was there. The regulatory and safety infrastructure required to support it was an entirely separate mountain. By the early 1960s, it was clear the Nucleon was not going to progress beyond its scale model. Reactor miniaturization was not advancing at the pace the late 1950s had suggested. The Atomic Energy Commission's own research into nuclear-powered aircraft, the Aircraft Nuclear Propulsion Program, was canceled in 1961 after consuming nearly $1 billion and producing no flyable aircraft. If the U.S. government could not make nuclear aviation work with unlimited funding and the full resources of national laboratories, a nuclear automobile clearly was not imminent. Ford quietly moved on. The Nucleon scale model passed into storage and eventually into the collections of the Henry Ford Museum in Dearborn, where it remains on display today. What the Nucleon left behind was not a technology, but a document. It preserved, in 3/8 scale, a precise record of what America's most forward-looking engineers thought propulsion technology was about to become. Every design decision in that model reflects the genuine technical knowledge of 1958. The rear placement justified by radiation distance. The elevated capsule mounting designed for accessibility. The turbine drivetrain chosen for its thermodynamic compatibility with steam generation. These were not cosmetic choices. They were engineering answers to real problems, even if the core premise never materialized. The designers weren't drawing science fiction. They were drafting specifications for a future they genuinely believed was 5 to 10 years away. The 3/8 scale model that Ford built is 8 feet long, and it sits low on white-wall tires that look entirely too small for the elevated rear reactor housing above them. It has its visual weight distribution completely reversed from every American car of the era. Everything that makes a car look planted and conventional, the heavy front end, the low hood, the engine mass riding over the front axle, is absent. The reactor deck gives the rear a crouched, elevated quality, unlike anything in production automotive design, before or since. In a museum context, surrounded by conventional production cars from the same period, it looks like it arrived from a different timeline entirely. Ford never built the Nucleon at full scale. No working prototype was ever constructed, and no nuclear material was ever involved in any physical version of the vehicle. The 1958 scale model was the full extent of the program's physical existence. The engineering drawings and concept documents remain part of Ford's historical archive. Whether the Nucleon would have worked as described had reactor technology eventually caught up to Ford's ambitions is a question that was never answered. But it stands as the most seriously engineered nuclear automotive proposal ever produced by an American manufacturer, developed at a moment when the idea did not seem nearly as impossible as it does now. Thank you for watching. If you want to go deeper on the Atomic Energy Commission aircraft nuclear propulsion program or the Chrysler turbine car road testing period, drop it in the comments and I will add it to my queue. Catch you next time.